Hey everybody, welcome back to Geometry with Mrs. Gunn. This is chapter 5.3, and this time we'll be talking about truth values and connectives. I know it sounds like I'm speaking Greek, but I'm going to explain to you and then it won't be hard at all. Okay, so truth tables provide a summary of truth values for statements. So for example, any statement P could be true or it could be false. If statement P is true, then not P has to be false. If statement P is false, then not P has to be true. Okay? A conjunction is a statement in which two statements P and Q are connected by and. The word and. The notation for the conjunction P and Q is denoted like this. P, and it looks like an upside down V. P and Q. You can remember that kind of looks like the A for and it's also very similar to the shape for intersection, which we also discussed previously means and. Okay, so this is P and Q. A disjunction, different from a conjunction, a disjunction is a statement in which two statements P and Q are connected by or. The notation for the disjunction P or Q is denoted like this. P with a big V, like that, P or Q. Okay? And that symbol, or, is very similar to this symbol, which we learned was union, and it means or when we're talking about inequalities. Okay? So that's how I keep them straight. Union and or, disjunction go the same direction. Conjunction and intersection and they both point up. Okay, so let's do a conjunction truth table. P can be true and Q can be true at the same time. P could be true and Q could be false. P could be false while Q is true, or P could be false while Q is also false. Okay? If we have and, remember we've talked before about and means both must be true at the same time when we were graphing. Well, it's true here too. When they're both true at the same time, P and Q is also true. But if either one is false, P and Q is false. If this one is false, this one is true, P and Q is false. If they're both false, P and Q is false. Okay? You can always reason this out, but we're going to work with these enough that it would be wise to just go ahead and memorize them. Okay? Let's talk about a disjunction truth table. We have the same scenario with P and Q. We could have both true. We could have the first one true and the second one false. We could have the first one false and the second one true, or they could both be false. But now let's talk about P or Q. What did we say or meant? Or meant where either or both are true. That was what we were using for or when we were graphing. Okay? So look what happens here. If both are true for or, the or statement is true. If this first one is true, the or statement is true. If the second one is true, the or statement is true. The only time the or statement is false is if they're both false. Okay, so what I've been saying about and or holds true for conjunctions and disjunctions too. For a conjunction to be true, both have to be true at the same time. For a disjunction to be true, either P or Q must be true to make the or statement, the disjunction, true. Okay, so you might as well go ahead and work on memorizing them, but until you memorize them, you can work them out. You can reason through it. Let's classify each of these statements as a conjunction or a disjunction and determine whether it's true or false. President Bush or President Obama is a Republican. So let's think about that. President Bush was a Republican. So this would be my P statement, and that is true. He's a Republican. My Q statement would be President Obama is a Republican. But that's false because he's a Democrat. So we have P or Q. P or Q. True, false. So what's my answer going to be from the truth table? P or Q, true or false, is going to be true. This is true. Okay? It's a disjunction. How about this one? Regular polygons are equiangular and equilateral. So my P statement is regular polygons are equiangular. My Q statement is regular polygons are equilateral. And this is and. So P and Q. So now think back. Let's see. Regular polygons are equiangular. Is that true? That is true. Regular polygons are equilateral. Is that true? It is true. So now let's look back to our conjunction truth table. If P and Q, both P and Q are true, P and Q, the conjunction, is also true. Okay? Now let's look at this one. Two lines are parallel or they intersect. So my P statement is two lines are parallel. My Q statement is two lines intersect. So I have P or Q. P, two lines are parallel. Well, I don't know. What two lines are you talking about? Okay. What about two lines intersect? Not necessarily. Two lines don't necessarily have to be parallel and they don't necessarily have to intersect. So I have a disjunction here and I have false, false. So look at my disjunction table. False, false, my statement P or Q is false. So if you have this case, if we can think of an example to be contrary to this, it's called a contradiction or a counterexample is what I'm trying to say. We could have skew lines. Skew lines are neither parallel nor do they intersect. So just because two lines are parallel or they intersect, you can't say that that's true because I could show you a pair of skew lines that are neither parallel nor intersecting. Okay? Okay, so this might not be typed in your handout. If it's not typed in your handout, just flip over on the back of the page and jot it down. Bicycle gears require oil and a coolant. So I need to decide what kind of statement this is and whether the overall statement is true or false. All right. So my P statement is bicycle gears require oil. My Q statement, bicycle gears require a coolant. And I have and. So this is P and Q. I started to put an A there. P and Q. So it is a conjunction. So is this statement true? Bicycle gears require oil. Well, that's true. You are supposed to oil them periodically. Bicycle gears require a coolant. I don't know any bicycle gears that require a coolant. So I have true, false for my conjunction table. True, then false. For a conjunction, true, then false. The overall statement is false because for a conjunction, they both have to be true to make the statement true. So where were we? Here we are. Okay. So this is a false statement. Okay. Here's a weird one. Brown is neither a primary nor a secondary color. Well, we haven't talked about nor yet, but nor does not equal or. They're not the same. Nor means and. Nor means and. So I could rewrite this as brown is not a primary color and brown is not a secondary color. Okay, so this is my P statement. This one is my Q statement. So I have P and Q. It's a conjunction. So let's determine if it's true or false. Brown is not a primary color. Well, that's true. The primary colors are red, blue, and yellow. Brown is not a secondary color. That's true also, because what are the secondary colors? Yellow, not yellow, I'm sorry, orange, purple, and green. Okay, brown is a tertiary color. So when I have a conjunction, true and true, look at the table, conjunction, true and true, the overall statement, the conjunction is true. So this would be a true statement. Okay, so true and true makes true. All right, let's go to the next page of your notes. Did that one? Okay, here we go. Make a truth table for this, M and N, and then this means or N. So what we're going to do is we're going to make a truth table for M and N. It's going to look just like P and Q, a conjunction table. But now we're going to go a step further and we're going to combine that with a disjunction table. So let me put a table here for us to get started on. Okay, so I made a table, and I'm going to make one column for M, one column for N, and I'm going to make one row for M and N. Okay, I thought maybe it would work better if I type it so I could have more space because it wasn't letting me draw in more space. So I'm going to have one column for M, one column for N, one column for this first part, M and N, M and N, and a final column for M and N or N. Okay, and we're going to need one more row here. And there's a way to do this, but frankly, it'll take me 10 times as long to do it, so I'm just going to draw it in. Okay. I never claimed these were high quality Hollywood videos. Okay, so let's think about just M and N. Our statements M and N, they could both be true, or the first could be true and the second could be false. Or the first could be false and the second could be true, or they could both be false. That part is always going to be the same, whether it's P and Q or M and N. Okay? Now think about your conjunctions. For a conjunction to be true, they both had to be true. Every other situation, the conjunction was false. Okay? Now what we're comparing is this column, M and N. This is our first thing. And so a lot of times what I like to do is I like to copy it. True, false, false, false. M and N is true, false, false, false. Then we're going to say or N. Well, N was true, false, true, false. And I like to write them. True, false, true, false. True, false, true, false. Okay? This is a disjunction or. So now think back to our disjunction table. Our disjunction table. They were always true unless we had two falses, and then it was false. So, here we go. Where do we have two falses? Right here. False. Every other time, oh, here's two falses also. If we had any trues at all, it was going to be true. So our final answer for this is this truth table. Okay? If M is true and N is true, then this kind of statement would be true. If we have true then false, then this kind of statement would be false, and so forth. Okay? Let's make one for this kind of statement. Here we have the conjunction A and B, and then we have the disjunction with not B. All right, so let me put a table up here. All right, so here's what my table looks like. I need a column for A and a column for B. And then these parentheses mean we're doing this part first, so I'm going to need a column for A and B, the conjunction. But over here I've got a not B, so I'm going to need a column for not B. And then finally I need a column for this disjunction, the final statement. Okay? So we always start the same. With statements A and B, we could have true, 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 false, false, true, false, false. And then we have the conjunction A and B. Remember, for a conjunction, it was only true if both statements are true. Otherwise, it was false. Now, how do we do not B? Look at B. Not B is the opposite. So if B is true, not B is false. If B is false, not B would be true. If B is true, not B is false. If B is false, not B would be true. So that's how you fill that one in. Now the last thing I like to do is I like to copy my A and B results. True, false, false, false. I like to put them here. True, false, false, false. And then I like to copy my not B results next to it. False, true, false, true. Okay. Now I'm thinking about a disjunction. So let's go back and look at my disjunction truth table. Okay. For a disjunction, it was always true unless I had two falses. Then it was false. So let's go back to that one. When I had two falses, my final answer was false. Otherwise, it was true. So this final statement, this would be my result. Depending on whether A and B are true, this is how my final statement would come out. Okay? So if A is true and B is true, then this statement would also be true. If A is true and B is false, this statement would still be true. If A were false and B was true, then my whole statement would be false, and so forth. Okay? Kind of goofy. Determining the number of rows. You want to know how many statements. Do we just have statements A and B, two statements? Do we have three statements, P, Q, and R? If we have n statements, here's how you figure it out. You need 2 to the power of n rows. So 2 statements, you would need 2 squared rows. 3 statements would be 2 to the third power rows, which would be 8. Okay? So n equals how many statements there are. N equals how many statements. Okay? So let's do a bigger one. Make a truth table. Oh, here it is. Make a truth table for P or Q and R. I've got 3 statements. So since I have 3 statements, I'm going to need 8 rows. So let me put that in here. So I made 8 rows, and I'm going to need columns for my P statement, my Q statement, my R statement. Then I'm going to need a column for Q and R. I keep wanting to cross that and make an A. Q and R. And then I need a column for, not a row, a column for P or Q and R. We're going to put them together. Okay? But I have 8 rows, and I need a column for each of the individual statements, then a column for what I have in parentheses here, and a column for my final. Okay, but it's always easier to add columns, but you need to know how many rows to start with. Okay, so how do we determine what to put here? Well, we could have P be true, Q be true, and R be true. Or we could have P and Q be true and R be false. Or we could have P be Q, P be true, Q be false, and R be true. Or P could be true, Q could be false, and R could be false. Or we could have P be false, Q be true, R be true. Or P could be false, Q could be true, and R could be false. Or P could be false, Q could be false, and R could be true. Or they could all be false. So those are my combinations. And the easy way to remember is the P's, we have 4 trues and then 4 falses going down. Q's, 2 trues, 2 falses, 2 trues, 2 falses. R's, true, false, true, false, true, false, true, false. If you can remember that, then you can easily fill in. Otherwise, you can reason through it the way we just did. Okay? Now we have to do Q and R. That's a conjunction. And remember, from our conjunction table, the only time a conjunction is true is if they're both true. Every time else is false. So let's go back to, where are we? This one, right here. Well, I'll find it in a minute. Here it is. Okay. We're just looking at Q and R. Okay. If they're both true, the answer is true. That one's not both true. That one's not both true. That one's not both true. Those are both true, so that's true. That one's going to be false. That one's going to be false. And that one's going to be false. Okay? The only time a conjunction is true is when both statements involved are true. Now what I like to do is, because I'm doing such a big combination here, I like to copy my P's back over. If you don't have to do that, if you can just look at them and keep it straight, but I like to do it so I don't get confused. My P column looks like this. And then I like to copy my Q and R column next to it. So that was true, false, 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 true, false, false, false. Okay? Now what we're doing is a disjunction. So a disjunction, look at my disjunction table, was always true unless I had 2 falses, and then it was false. So let's go back. It was always going to be true unless I had 2 falses. Where do I have 2 falses? Down here I do. 2 falses make a false for a disjunction. Everything else is going to be true. Okay? So this is the answer for this column. This is my work. This is helping me to keep everything straight. Okay? Okay, so now we need to make a truth table for this. Not S and the quantity S or T. So how many columns am I going to need? I'm going to need a column for S, for T, for not S, for S or T, and then the whole thing. So I'm going to need 5 columns. And how many rows am I going to need? Well, I only have 2 statements, S and T. So 2 squared would be 4 rows. So give me a second to put that up here. Okay, so here we go. I made a column for S, for T, for not S, for S or T, and for not S and the quantity S or T. All right, and I've made my 4 rows. So my beginning's always going to start the same. With 2 statements, I'm going to have either true, 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 false, false, true, or false, false. Those are my 4 combinations. Not S is going to be the opposite of S. So if S is true, not S is false. S is true, not S is false. S is false, not S is true. If S is false, this will be true. Okay? Now I have to look at S or T. S or T is a disjunction. My disjunctions, remember when I looked at them, the only time I got a false was when I had 2 falses. So let's go back to this one. The only time I would get a false is if I had 2 falses. Right there I have 2 falses. Every other time is going to be true. Okay, now I have to put them together with an and to make this a conjunction. Okay, so I like to write my not S here first. So false, false, true, true. And then I like to write my S or T next to it. S or T is going to be true, 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 false. Okay, now it's a conjunction. So my conjunctions were, if I had 2 trues, it was true. Otherwise, it was false. So let me see where I have 2 trues. Right here. 2 trues is a true statement. Every other time is going to be a false statement. And that's my final answer for that statement. Okay, so I've got a few more examples I could do, but I think you guys probably get it. I wanted to talk to you about some things in the homework. On page 172, tell whether the following statements are disjunctions or conjunctions, and then tell whether they are true or false. Okay, so number 1, a spider is not an insect, or a porpoise is not a fish. Notice that number 1 has an or in it, and or means disjunction. Okay? So in order to determine whether it's true or false, you're going to need to look at a truth table, because what you're being given is a P. A spider is not an insect, so you're being given a not P, because if P would be a spider is an insect, then not P would be spider is not an insect. Okay, so you're being given not P or a porpoise is not a fish. That would be Q is a porpoise is a fish. A porpoise is what we normally call a dolphin. So not Q would be porpoise is not fish. So they're giving you not P or not Q. So you're going to need to look at a disjunction table for not P and not Q to determine whether this is true or false. So when you're reading the statements, if you're not sure, think about what the truth tables would show. Okay? Then the next section on page 173, numbers 11 through 14. There are some hidden ands in there. Okay, number 11, orange is made from green and yellow, while lavender is made from red and blue. While equals and. Okay, number 12, snow is falling outside and it is 83 degrees outside. That one's obviously got an and in it. 13, 5 plus 3 is 8, but 5 times 3 is 15. But is the same as and for our purposes. 14, Venus is a star, semicolon. The sun is a planet. Semicolon is also an and. Okay, so keep those in mind when you're working on those. And then 15 through 19 is just making some truth tables. Look at number 20. Compare exercises 18 and 19. What do you conclude? And by that, I mean, number 20, If you look at 18 and 19, they're the same letters and symbols. The only difference is that in 18 we group P and Q first, and in 19 we group in parentheses Q or R. Okay? So what it's asking there is, does it make a difference? Which we group. First. So can we use the associative property? Okay. Does the associative property make a difference? Okay. Are the answers going to come out the same? All right. That's what that means. Good luck. Give it a shot. I'll see you soon. Bye.